student, here I will discuss how the conductivity of semiconductor depends on electron hole concentration, as well as there is one more term, the drift velocity of electron. What is the effect on drift velocity of electron? I have learned in chapter 3 the relation between the current and drift velocity. We will be using that. So in semiconductors, the charge carrier are electron and hole. In this figure, a piece of conductor, semiconductor length L, area A, is connected across a source of V volt. When we apply V volt, an electric field is set up across the semiconductor, which drift holes and electron. Holes move in the direction of current, electron move opposite to. But total current I will be equal to IE plus IH, and IE is equal to NE into E A VE plus NH E A VH. We have learnt I equal to NeAVD. So here Ne means number of electron per volume, charge of electron, A cross-section area, VE drift speed of electron, number of hole per unit volume, E charge of electron, A cross-section area, and VH hole velocity, drift velocity. I equal to actually semiconductor supposed to obey Ohm's law at low potential. So I equal to V by R. Here E a common, NeVe plus NHVH. Now from chapter 3 we know V equal to E into L and R equal to rho L upon A equal to EA into NE into NH plus VE NE into VE plus NH into VH. This L cancel, or EA upon rho equal to E bracket NeVe plus NHVH. A cancel, 1 upon rho E into NeVe plus NHVH upon E, or we can write it as 1 upon rho, reciprocal of resistivity, conductivity. So sigma equal to E into Ne mu E plus NH mu H, where mu E VE upon E and mu H VH upon E, and mu E and mu H here mu E and mu H are called electrons and holes mobility. Electron hole mobility. This mobility is defined as drift velocity of electrons and holes. Drift velocity of electrons or holes per unit electric field. So mu E its unit is meter per second. देखो, it is V upon E, meter per second or volt per meter. So it is meter square per second per volt. Unit is meter square per volt per second. So we get sigma is equal to conductivity dependent on number of electrons and holes. And you know, holes show conductivity when they are present in conduction band. Valence band, and electron in conduction band. And these are number of electron hole per meter cube taken. So from this we find that conductivity of semiconductor depend on concentration of electrons and holes and their mobility. The conductivity of semiconductors depends on electron hole mobility and their concentration. Now I told that conductive semiconductor increase with the increase of temperature. Conductivity of semiconductors increase with increase of temperature. So, is there any effect of conductivity due to hole? So, at a given temperature, conductivity of semiconductors depends on concentration of electrons and holes, and also on their mobility. But mobility of electrons and holes does not change significantly. Means electron hole mobility ultimately has no effect of temperature on them. So on increasing temperature, the conductivity depends, the conductivity increases on increasing temperature, the conductivity of semiconductors increases due to increased number of electrons in conduction band and holes in valence band. We can't ignore the role of mobility of electrons hole at any temperature. That has the effect. For every semiconductor, for every semiconductor, मतलब semiconductor silicon germanium, pure semiconductor and then doped semiconductor, whosoever is there. By every conductor has charge carrier, has electrons and holes. If it is pure or impure, सब में इलेक्ट्रॉन होल हैं. हाँ, that is another fact कि in n-type semiconductor conductivity is due to electrons, because electrons are big in number. I have told you a question there. I have told two questions just now. For every semiconductor, electrons mobility is little higher than holes mobility. Holes mobility, and therefore if we have n-type and p-type semiconductors, of equal dopant concentration, then n-type semiconductor is better semiconductors. This question has been asked in board exam class 12. If we have two pieces of semiconductor having equal dopant concentration, one n-type, other hole type, which is better conductor? It is because of electron hole mobility. So remember this equation, E into Ne mu E plus NH mu H. The role of electron hole mobility is there. Whosoever is the semiconductor, electron mobility is higher than hole mobility, and therefore if number of electron holes same then and they are separately na, so n-type semiconductor will show better conductivity. Now one thing more, I have told you pure semiconductor or doped intrinsic semiconductor and type p-type. So there is energy gap between valence band and valence band and conduction band. So one question was there, if when we dope a pure semiconductor with pentavalent or trivalent, then energy gap will increase or decrease. So you know it is valence conduction band here, it is valence band here. This is the energy gap which is less than 3 electron volt. Now when you dope it with pentavalent atom, the energy level of donor atom, यानी कि donor energy level, donor energy level lies just below the lowest energy level of conduction band. So now energy gap supposed to be this, because electron can get this much energy from electric field. So that way, when we dope a pure semiconductor with pentavalent or trivalent atom, the in case of p-type semiconductor, it is the energy accepted energy level. Again, here gap is this. So on doping the pure semiconductor, the energy gap between valence band and conduction band decreases. This is very important video here, because all these descriptions are not given in NCERT book. Some books follow and mostly all book follow this NCERT book, so they don't have this relation explained. This relation has not been explained. Please watch this video carefully, make the notes. Sorry, I'm telling one information here in this video. Actually, I had prepared this video, but there were some mistakes. I deleted that, and now I'm loading this again after. So the video done before this actually was prepared later and not earlier than this. So you can arrange it. Thank you.